Hello students, let us do velocity and acceleration, and this is also considered as an application of vector calculus. So now if you go back and think about what exactly you have studied in velocity and acceleration, first let me tell you generally, then we will come back to our topic in maths. See, we all know that distance is usually represented by x. And what is velocity? Velocity is rate of change of distance. That is the reason velocity is represented by dx by dt. Correct? Same way, acceleration is rate of change of velocity. So that is the reason acceleration is dv by dt. But we know that v is dx by dt. That's why acceleration is second derivative of distance and velocity is first derivative of distance. So this is what you have studied in physics, or in earlier grades you have understood like what is distance, what is speed and all that stuff. Now when we come to a vector fields, okay, suppose P is any point with the coordinates x, y, z, then R bar represent the position vector. Okay, if this R bar is a function of variable t, then the velocity v is given by dr by dt. Instead of dx by dt, now I have a dr by dt. And we know that this derivative dr by dt, it is the velocity of a particle at any time t. Now acceleration is rate of change of velocity. So dv by dt, and this v can be replaced by dr by dt. So this is the acceleration. Acceleration and velocity both are vector quantities, right? So now when you take the magnitude, so magnitude is represented like this and magnitude of acceleration is represented like this. And we all know how to find out the magnitude of a vector. Geometrically, this dr by dt is vector along the tangent and hence known as the tangent vector also. So what type of question I can frame here? I will give you r and I may ask you find velocity at this point. I may ask you find acceleration at this point. I may ask you find the magnitude of velocity. I may ask you find the magnitude of acceleration. And I may ask you find the tangent vector. So when I am asking tangent vector means I am asking velocity only. Okay. Now in gradient, when I was teaching you, I told you gradient is rate of change of function along the normal and it will have component in all the directions, right? So same way I can find out the component of velocity and acceleration. How to find out the component? If you remember, directional derivative was the component, and directional derivative, suppose if I am finding out for grade phi, so grade phi dot n cap. Okay, same way if I want to find out the component of velocity in the direction of any vector n, then that component is given by v dot n cap, where n cap is a unit vector where in which direction I need the component. Same way I can talk about acceleration. So this give me the components, right? Now, so this is the same thing, component of any vector A along any direction D is given by this, the dot product of vector and n cap. Okay. Now when I say the component of this perpendicular to the vector D or along the normal D is A minus resolved part of A along D. So the direct formula I can use is this. Okay. So now let us apply these small concepts to the questions. Now my first question is x, y, z is given. So first I will frame what is r. So I know that r vector is t square plus 1i plus 4t minus 3j plus 2t square minus 60k. Okay. So now, what is the first question? Unit tangent vector. As I said, tangent vector is nothing but the derivative of this r, which is basically a velocity. So I'll find out dr by dt, which is equal to 2t I plus 4j plus 4t minus 6k. Okay, so this is only the tangent vector. My question is unit tangent vector. Unit tangent vector is nothing but dr by dt upon magnitude of dr by dt. Correct? So I need to find out this magnitude as well. So it will be 2ti plus 4j plus 4t minus 6k upon under root of 4t square plus 16 plus 4t minus 6 ka square. Right? So this is your unit tangent vector. You can open this and simplify this as well. Okay, let me show you. So this will become 2ti plus 4j plus 2t minus 3k upon 4t square plus 16 plus 16t square plus 36 minus 48t. So this will be equal to 2ti, or let me take 2 common, plus 2j plus 2t minus 3k. Okay, this will become 16 plus 4 is 20t square, right? So 20t square, then minus 48t plus 16. If you observe, 4 is a common factor in the denominator, which when come out, that will be 2. So 2 will get cancelled, and I'll get ti plus 2j plus 2t minus 3k upon under root 4 went, so 5t square minus 12t plus 4, right? So 5t square minus 12t plus 4. Just have a look here. See here, it is, I forgot to write this term, 36 plus 16 it is. So it will become 2, 1 carry over, 3, 4, 5, 52. So this will become 13. Right? So this is unit tangent vector. What is the second part I asked? Find the angle between the tangents at t is equal to 1. Look at this. At t is equal to 1 and t is equal to 2. So now what is a tangent vector? Tangent vector is this. So I need to find out this value, the value of this function at t is equal to 1 and t is equal to 2. Let me call it, at t is equal to 1, let me call it a. So when I put t is equal to 1, what I'll get? 2i plus 4j minus 2k. At t is equal to 2, this will be b. I am just naming it. So it will be 2 if I am putting 4i plus 4j plus 10k. Correct? Now, how to get the angle between the two terms? So angle between two vectors is cos theta is equal to a dot b upon magnitude of a and magnitude of b. So here when you do the dot product, we all know dot product means multiplication of this 2 and this 2. So 4 2s are 8 plus 16 minus 20 upon under root 4 plus 16 plus 4 and 16 plus 16 plus 100. Okay. So 16 minus 20 is minus 4. So basically 4 plus 4, and denominator 16, 20, 24. So root 24, and this is 132. Right? So when you solve this, you will get 5 3 root 6, which will be the answer. So this will give you the value of cos theta. Okay. Okay, see here, this mistake I have done, small mistake. When I am putting t is equal to 2, 4 2s are 8. 8 minus 6 is 2. By mistake I wrote 10. So it is 2. So here it will be 8 plus 16 and it is minus 4. Correct? So and here also 16 plus 16 plus 4. So this will become cos theta is equal to, so 8 minus 4 is 4, 16 plus 4 is 20 upon, this is root 24 and this is 16 plus 4 is 20, 36, 36 is 6. Right? So when you solve this, this is 5 upon 3 root 6. So this is the answer. Okay. Now let's move to the next question. Find unit tangent vector for this. Again, unit tangent vector means dr by dt. Okay. So v cos t I plus 4 sin t j plus 3k. Here it should come minus, right? Now unit means I need to divide it by its magnitude. So first let me find out the magnitude. Square root of 16 cos square t plus 16 sin square t plus 9, which is equal to sin square plus cos square is 1. So 16. 16 plus 9 is 25. 25 is 5. Right? So what is the answer? Answer is equal to, unit tangent vector is equal to 4 cos t I minus 4 sin t j plus 3k upon 5. Correct? So this will be my answer. Right? So let's move to the next question now. So now what's the next question? A particle moves along curve this. Find velocity and acceleration at t is equal to 0. This is very, very important question. Okay. Okay, so let us start with this. Now, what is r? What is the position vector? Xi plus yj plus zk. So, e to the power minus t I plus 2 cos 3t j plus 2 sin 3t k. Right? Now, velocity means dr by dt. So, it is minus e to the power minus t I minus 6 sin 3t j plus 6 cos 3t k. And this velocity I need at t is equal to 0. So, velocity at t is equal to 0 is equal to, e to the power 0 is 1. So, minus I, then sin 0 is 0, so it is gone, plus 6 k, because cos 0 is 1. Right? So, this is the velocity at t is equal to 0. If I ask you what is the magnitude of velocity, though it is not asked in the question, at this point, then it will be under root of 1 plus 36, that is root 37. Okay. Now let's do the acceleration. So acceleration is dv by dt or d2r by dt square. So again differentiate this sentence. So this will become e to the power minus ti minus 18 cos 3tj minus 18 sin 3tk. At t is equal to 0, this is I minus 18j, because now k term will become 0, as we know that sin 0 is 0. Right? So this is the acceleration. If I want to find out the magnitude of acceleration, what I will do? Under root of 1 square plus 18 square, which is equal to under root 325. So this is how you should do the question. So this is very direct question and very important question. Okay. Now look at this one. Again the same thing. A particle is moving like this. Find velocity and acceleration. Right. So first you frame your r. R is 1 minus t cube I plus 1 plus t square j plus 2t minus 5k. Now dr by dt, that is the velocity is equal to minus 3t square I plus 2tj plus 2k. Okay. Now acceleration is d2r by dt square. So minus 60I plus 2j, and this will become 0. Correct? So I got velocity and acceleration. They have not given me any point. So I will also leave it here only. Now look at the second point. Find component of velocity and acceleration at t is equal to 1 in the direction of this. Okay. So now see, this is important thing again. As directional derivative, suppose I am finding out component for something A. So that A dot n cap I have to do. So now what is n given here? 2i plus j plus 2k. So what is n cap? N cap is a unit vector along this vector. So 2i plus j plus 2k upon under root 4 plus 1 plus 4. So my n cap is equal to 2i plus j plus 2k upon 3. Okay. Now the first thing is find the component of velocity at t is equal to 1 in direction of this vector. So I did this first. So now you find out what is the velocity at t is equal to 1. So velocity at t is equal to 1 is minus 3i plus 2j plus 2k. So the component is the velocity, since I am finding out the component of velocity, dot in which direction? In direction of n. So what is n cap? This. So that you should write 2i plus j plus 2k upon 3. So now how to do the dot product? Minus 6 plus 2 plus 4 upon 3. So this is 6 minus 4. So the velocity component is 0. So in this direction the velocity component is 0. Okay. Now let's talk about the acceleration component. So first find out acceleration at t is equal to 1. Okay. So t is equal to 1, acceleration is equal to minus 6i plus 2j. So now when I am doing the component, what will be the formula? Minus 6i plus 2j, that is acceleration, dot. In which direction component? In this direction. So now let's do the dot product. So minus 12 plus 2 upon 3. So minus 10 by 3. So these are the component of velocity and acceleration. One thing also you take care, if I ask you find the component of acceleration in tangential direction. So what is a tangent to a acceleration? Velocity. Means I am asking you the component in the direction of velocity. So in that case what you should do? You should do A, because I am finding out its component, and in the direction of velocity means v cap. Okay. Because if you remember in the beginning I told you velocity is a tangent vector. So that's why if I ask you find the component in tangential direction for acceleration, then it is v cap. Okay. So in place of n, that is v cap. So remember, directly take velocity. Okay. Now come to the next question. A particle moves along this curve. Find component of its acceleration at t is equal to along tangent and along normal. So now see here. This is what I was telling actually. R is equal to t square plus 4ti plus 8t square minus 3t cube. Oh, I missed one term. 1 second. So t cube minus 4ti plus t square plus 4tj plus 8t square minus 3t cube k. Okay. So velocity is dr by dt, which is equal to 3t square minus 4i plus 2t plus 4j plus 16t minus 9t square k. Correct? And then this velocity I need at t is equal to 2. So t square is 4. 2 square is 4. 4 3s are 12. 12 minus 4 is 8. So 8i plus 2 2s are 4. 4 plus 4, 8j plus here 16 2s are 32 and 9 4s are 36. 32 minus 36 is 4. So this will become minus 4k. Right? Now acceleration is dv by dt or d2r by dt square. So 60i plus 2j plus 16 minus 18tk. Now this also I need at t is equal to 2. So this will be equal to 12i plus 2j plus 18 into 2 you do 36. So 36 minus 16 is 20. So this will become minus 20k. Right? So I got the velocity and acceleration at t is equal to 2. Now what exactly I need to find out? I need component of acceleration. So when I'm saying component of acceleration means first thing, so I should write acceleration dot. In which direction? Along the tangent. Along the tangent means along the velocity. So I should have v cap here. Correct? So now this is 12i plus 2j minus 20k dot. V cap means what? V cap means 8i plus 8j minus 4k upon under root of 64 plus 64 plus 16. Correct? So now this dot product I will do. So 12 8s are. So 12 8s are, first you check this, what is the denominator? 64, 64 and 16. So 10, 14, 4, 1 carry over, 12, 13, 14, 144. So root is 12. So 1 by 12. And if you do the dot product, 12 into 8 you do 96 plus 16 plus 80. Right? So this will become 192 by 12, which is 16. Okay? So now next, this is component of acceleration in tangential direction or in direction of velocity. Both the terms are exactly same. Okay? So don't get confused by that. Now the second part of this question is in the direction of normal. And I told you for the normal, what is the formula? The formula is a vector minus resolved part of a along tangent. Okay. So what is a? A is our acceleration only. So 12i plus 2j minus 20k minus. Now what is this thing? Resolved part along the tangent. So resolved part along the tangent, if you remember this formula I told you, a minus a dot n cap into n cap. In the beginning I gave you one formula. That formula you apply, and when you solve it, it will be 16 by 12, 8i plus 8j minus 4k. Okay. So now magnitude of this is required. So you just open this. This is 1 by 3, 4i minus 26j minus 44k. When you find out the magnitude of this will be under root of 292. Okay. So this is how you can find out the component in the direction of normal. Usually they don't ask this, but if they ask, you should know. Okay. Now, position vector r is given by this. Find the tangential and normal component of acceleration at t is equal to 1. So now first, velocity is equal to dr by dt is equal to 2ti minus 3t square j plus 4t cube k. At t is equal to 1, this will become, let me write here, 2i minus 3j plus 4k. Okay, so this is velocity at t is equal to 1. Now acceleration is equal to 2i plus 6tj plus 12t square k. Acceleration at t is equal to 1 is 2i plus 6j plus 12k. Okay. So now this is minus, why I wrote this plus, this is minus. Okay. So now I got this. Now the next thing what they are asking, tangential component. Tangential component means the component of acceleration in direction of tangent. In direction of tangent means what? In direction of velocity. So the tangential component will be 2i minus 6j plus 12k. That is the acceleration. Dot. Unit vector for velocity means 2i minus 3j plus 4k upon under root of 4 plus 9 plus 16. Correct? So this will become 4 plus 18 plus 48 upon, this is 20, 29, root 29. So this is 70 root 29. So this is tangential component. Okay. And for when we are talking about normal component, this is tangential component, normal component. So I'll take back you to the first page where I gave you the formula so that you should not get confused, because the formula was little lengthy. See, this is what I gave you. The same thing you have to do. What you have to do? Acceleration dot n cap into n cap. Right? So now when you will solve this, so now normal tangential vector will be equal to magnitude of 2i plus minus 6j plus 12k, which is your acceleration, minus the tangential component. So 70 upon root 29 and 2i minus 3j plus 4k dot root 29. Compare it with the formula. I told you the resolved part, this is the resolved part. So 70 by root 29 and n cap. That is what we have written. Right? So now you solve this. So you will get the answer as 1 by root 29 under root minus 82 square plus 36 square plus 68 square. And when you solve this, it will be under root of 436 by 29. So you can cross check, you can solve yourself and cross check the answer. So this was a very small topic and application in velocity and acceleration. Sometime they ask one question on this, and most of the time they asked you the direct velocity, its magnitude, or acceleration, its magnitude, and very rarely they ask the component, and if they ask the component, they ask the tangential component. Okay, but then also we have practiced normal component as well. So I hope this topic is clear to all of you. So practice a lot of question. All the best for your exams. If you have problem in any topic, put in the chat box. I'll try to create the video for it and upload in the channel. Thank you.